Welcome, everyone. This is Jim Sporer. I'm the founding board member of ISSIP, the International Society of Service Innovation Professionals. It's my great pleasure to welcome Armand Maghboula, COO of Luna XIO. And Armand has a talk about the ISSIP Excellence Award-winning overall winner presentation for this year, 2023. I just want to mention that ISSIP runs this award annually. Nominations for 2024 are open. Every winner receives a trophy and digital certificates for each of their members. This is the ISSIP blog post that talks about all the winners. This is the first year we had an overall winner for the Luna BLE-to-cloud protocol. And without further ado, I'm going to show the video that Armand sent me. So let me go ahead and stop sharing and bring that up. And here we go. And I believe your opening phrase is, does everybody remember when they first started shipping the COVID vaccine? So get ready, here's the video.
Do you remember the day the vaccines were released? I remember seeing the pictures of the trucks rolling out, people clapping along the way, and it was a marvel to develop it in real time, and it was going to be a massive undertaking to have a distribution nationwide with these vaccines that had to be kept at very low temperatures. And there was a command and control center. They could see where the trucks are at any time. If there's weather events, reroute around them, traffic, all of these things. It was quite impressive. At the time, I remember thinking, well, this Internet of Things thing is a thing. It's quite good. It's very useful. But then at the same time, you look at it and say, the original promise was much greater than just, once in a decade to be used in vaccines, right? There was a promise of reduce food wastage. And today we still have $35 billion a year of food that's perished. There's still $8 billion of equipment that are lost in hospitals in the US alone. The supply chain still doesn't really have the visibility that we need. And the question is, what went wrong? Okay. Now, I'm not saying that just because somebody in 2012 said some things that you should live up to. Personally, I have no problem that my refrigerator is not ordering milk by itself. A-okay. Some of the other outlandish predictions that have not come through, no problem with those. But I do talk to operations people, supply chain, in healthcare, in manufacturing, and they do want to go to the next level. And they don't think it's sufficient where we are right now, where we can monitor trucks of vaccines, but not go deeper, not go to the next level. So let me tell you what next level means for these folks. For people who are sending perishables, the next level for them is to be able to go to be monitoring temperature within the truck in real time and at multiple points, right? Right now, there are data loggers where you can monitor the temperature at the end, and then you have the truck telematics that monitor location in real time. But what you really need is to be able to see what's happening inside the truck, be it produce, pharmaceuticals, or live animals that are being transferred. You want to be able to look within the truck in real time at multiple points. That's the next level for them. For somebody who is doing asset tracking, next level for them is, okay, we can keep track of really big, expensive things like dialysis machines. But an oxygen tank is also important, right? It's much smaller, lower value, but it needs to be able to be tracked. That's the next level for asset tracking. The next level for example, for vitals monitoring is that it's great that a patient in a hospital room can be monitored, can have their vitals monitored, but the next level would be to be able to do that in the ER before they're fully admitted, or even better, at home for inpatient, for at-home care. So that's what the next level means for people, and we're not there, right? Where are we? where we are is that if you want to be able to monitor a truck, you can get one of these truck telematics. You can see a picture here. It plugs into the truck power, and you're good to go. But where you really want to be for that next level, for that next 100 billion devices that need to be connected and need to be made visible, is that the trackers, the sensors themselves need to be much, much smaller, right? Something that's pillbox size needs to be able to last 10 years. To be at the next level, you want to have broad connectivity, right? You want to have something that is not just in a particular area, in a particular town that has LoRa, or in a particular warehouse location where you've instrumented it. You want it to be across the whole supply chain, wherever it is that the assets might go. And last but not least, it can't require huge new infrastructure. It's a non-starter to require additional wiring to be done in the truck or in the warehouse or anywhere. I can't even get somebody to fix an outlet in the house, let alone to be doing this sort of a thing across the whole supply chain. So what you really need is something, again, that's can be able to be very small, low power, can have broad connectivity, and not require additional infrastructure. So let's look at the first part of the solution. You're actually extremely familiar with it. It's called Bluetooth. Bluetooth has been extremely successful. It is amazing how wide a distribution it has. There are 5 billion devices, Bluetooth devices, that are manufactured every year. The advancements both in size and power requirements are incredible. The cost of a basic Bluetooth device bill of materials has gone down from $10 to less than $1. And there's so much R&D behind it, both in design and in production. And last but not least, so many internet-capable devices like mobile phones and barcode scanners are Bluetooth capable on one side and internet connected on the other side. So Bluetooth as a technology, Bluetooth Low Energy, is an extremely attractive part of the solution. Now, where Bluetooth fails is that it was designed as a local connectivity solution, right? So a Bluetooth speaker pairs with a Bluetooth phone, right? And that does not really play well in an industrial commercial setting, right? You really need automation in this world, and the automation is driven by the cloud, right? So what you really need is a solution that connects the Bluetooth device to the cloud, and it's that the automation and the orchestration can take place from the cloud level. And that's precisely what Luna provides, right? We've had a model of this sort of connectivity that has worked extremely well for us for the last 30 years. It's called the internet, right? And the internet, when you go on your laptop at your house and you connect to a bank, your browser makes a secure connection directly to the bank, and as far as they're concerned, they just see each other. Then it's at another layer that your Wi-Fi access port is active. And yet in another layer, that's the fiber optics cables. And this layering and this security provides the great flexibility that has made the internet successful, and we believe is what's required for the next level of the Internet of Things as well. Let me show you what the Luna equivalent of the connection model looks like. On the upper right-hand side, we've got the Bluetooth devices, be they trackers or sensors, or even patient monitoring or other devices that happen to have Bluetooth on them. And they make a secure encrypted connection with the cloud, and I can go through how that happens. And the key is that the medial points in that connectivity, the gateways, as we call them, the things that speak Bluetooth on one side and have internet connectivity on the other side, those are the different encryption layer and do not have to be part of the setup part of the use. in there. So all they have to do is pick up the signals from the air, pass it on. They pass it on to a routing service that we provide because everything's encrypted. Then the application, the agent, as we call it on the right-hand side, comes and picks up what it needs from our routing service. So that's the basics of the Luna technology, the Luna protocol itself. Let's go through the implications of that setup. We've all had the experience of connecting Bluetooth speakers, right? You go and you have to press a button. Sometimes you have to read a code or hear a code and verify a code and then approve the connection for the pairing to take place, right? Now, try doing this with 10,000 trackers or 100,000 trackers that would be used in an industrial setting. It just doesn't fly, right? But if the connection is between the device and the cloud, right? So for example, when you buy a Luna device, the Luna device comes pre-programmed with a factory key, and that factory key is communicated to the application out of that, let's say by email or by some sort of an API push. So you buy 10,000 devices, you get 10,000 keys delivered on the other side. When the actual equipment arrives on your premises, somebody presses a single button, says, hey, look, this batch of trackers has arrived. Then the cloud has all the factory keys and can communicate with the devices saying, hey, wake up, and let's engage in a key exchange very much like SSH does, so that we can have a connection together. And at that point, we call it onboarded or provisioned, right? So this whole process of pressing buttons 10,000 times and figuring out and having to have people present really goes away. And that's, you know, immediately, even before you start using the trackers or the sensors, the security model automates and makes things easier. Okay. Once you start using it, the very basic use is, for example, is for locationing, right? There are beaconing products available in the market today, but if you look at all those existing protocols, you know, the Edisons and the iBeacons, the way they work is that the devices basically advertise their ID on a regular basis, right? And these advertisements get picked up by a cell phone, for example, and the cell phone adds its own position and forwards it onto the application, right? But it's not just the cell phone that adds its position. It's very easy for a bad actor to just be listening to an ID and start spoofing it. Right? Doesn't take much. Oh, this device is not here. It's actually out in China, but whereas when it really isn't. And even worse, this location can be snooped nowadays, meaning that a bad actor that puts in listening devices at different locations sees one ID 5582 at the warehouse, sees that 5582 at a point of transport, sees the 5582 at a distribution center, and says, hey, look, that's the path of 5582, right? That sort of insecurity is not viable in a commercial setting. So with Luna, what you get is that because the endpoint and the cloud are able to trust each other and have a secret key, they have a mechanism, Luna provides a mechanism for them to be changing the ID on a regular basis, to have an ephemeral ID, so the ID doesn't last very long, so that even if there is a bad actor listening, they can't spoof it because by the time they try to spoof it, that ID has expired. Or if the bad actor is listening at multiple locations, it's a different ID from that same asset that's being broadcast. So they really can't piece it together. Okay. So that's in the regular beaconing world, the value of Luna is on that security and privacy side. The second value of Luna is in bidirectional communications. The bidirectional part of it being that because the device and the cloud can trust each other, the cloud can send commands to the device that are secure, and the device can feel free to listen to those messages or follow those commands. It doesn't sound like a big thing, but in practice, it's huge, right? Even for the very simple locationing, it's very useful to be able to have something that's bidirectional. As you can imagine, in industrial settings, a lot of the time, the location that's important is within a building, right? Within a warehouse, within a hospital, within a factory. And GPS does not work within buildings, And it's very difficult to get to meter, sub-meter accuracy, which is what's often needed. If you're one side of it in the hospital, which room is it in? Or if it's in a warehouse, is it on this shelf, below this shelf? That's very important. It's very difficult to get to sub-meter accuracy, but it's easy to get to something like 10-meter accuracy. So if you're at the 10-meter, then the fact that there is an ability to issue commands to the tracker allows a workflow such that you get the person to that 10-meter, press a button, and then the device itself flashes and makes sound to make it possible to get to cover that last 9 meters, to go from that 10-meter to where the item is located. Okay. So that really simplifies a lot of the indoor locationing problem for asset tracking. Bidirectional communications is extremely important for communications, for sensor communications. You already see it, pilots say Roger, truck drivers 10-4. You and I, as we speak, we nod to acknowledge that we understood a message. And that same mechanism is also extremely important when you're communicating temperature information, for example, right? You can't have the sensor just always be spewing out, oh, here's the temperature, I'm not sure if anybody has received it, so let me keep sending it, let me expend energy saving it, sending it, let me expend memory maintaining it. No, it really should be that the sensor has some information, the cloud asks for it, the sensor sends it, the cloud says, I received it, end of story. Get rid of unnecessary spewing and unnecessary usage of memory. Yeah. So we've talked a little bit about the technology, we've talked about the implications. Let's look at how these things are used in real life. Okay. I want to go back to the blueberries, to the perishable goods. Right? So we provide a service, for example, in a company where the inside of the truck, we can install multiple, let's say 3 or 6 of these sensors to be able to be aware of the temperature and humidity and light and other things within the truck, and have that information be transmitted in real time through the driver's mobile device, be it a barcode scanner or a phone or whatever that would be. The setup is robust because, like I said, everything is acknowledged. So if the truck is in an area where there's no connectivity, no cellular connectivity, the data is stored long enough until the connectivity is restored, and then it is set. And that's very simple. And these 3 to 6 sensors, with batteries that last 10 years, cost actually less than a single truck telematics device would. Okay. Extremely useful. Second use case on asset tracking. Like I said, there are relatively small trackers like this one that can be attached to oxygen tanks that are at price points that make it feasible to be monitoring and have visibility into large number of assets across the country or internationally, as the case may be. We also have the notion of for monitoring, like vitals monitoring. The idea is that you can have a blood pressure and temperature monitoring device that's attached to a person that has a long battery life, where its connectivity comes through, for example, a tablet that's also provided for patient care. And the key that Luna provides here is that everything just works. The caregiver does not have to be involved in pairing or associating or making things work. Just that as long as they're in the vicinity and there are other mechanisms set up for keeping these things charged, the data just goes. Okay. Last but not least, this is a subtle use case difference, is that a lot of times you're not looking to just be monitoring at the transport, at the truck. I was talking to a technology forward executive at a pharmaceuticals company, and he said, we care more about our drugs and the well-being of those drugs than any warehouse provider, than any transportation provider. He was saying that they need that information, and they want it to be not just in the segments of a truck or a warehouse, but to be end to end. So what they really want is something that's inexpensive, that can be attached to a pallet, to a box of medicine or goods, that really goes through the whole life cycle, and automatically in every location the information gets to them, and potentially, of course, to the transport provider or the warehouse provider, but that they are the ones who want to be receiving that information. And the ability to have again, low-powered, small device that can attach very easily, that can go through these, what we call neutral gateways, basically. It doesn't matter which transport provider it goes through, as long as they have the app on there, the information gets through. That becomes very key. So we've talked a bit about the technology implications and some use cases. I want to talk about a little bit about how some of the things we're excited about going forward. The hardware advances on Bluetooth are amazing to me. You can see a picture of one of the dialogue chips we work with. It's extremely small. You see how it is barely visible on the tip of a finger. Amazing power profile. And we're very excited that people are working extremely hard to get these things into smart labels, into flexible form factors that can very easily be attached on top of packages, for example. That opens up a whole new world of visibility. And those sorts of advances in the hardware world are perfectly made for something like Luna, because it allows the hardware manufacturers to do what they do best and rely and be able to expect that there is a communication network underneath that just works, that does not require a whole new large infrastructure to make it work. Some of the stuff we're working on in the future is on the standardization aspects. We really have seen and believe that the internet was successful specifically because of its open protocols, standard protocols. And we are in the process, a three-stage process of standardization. First, standardizing the communication between the devices and the gateways, and then going further on from the gateway to the router, and also significantly making that router portion of it standardized, such that you can have federated routers, or more importantly, really private routers for extremely sensitive applications where you don't want the information to go onto the internet at all. So I really want to thank the ISSIP for creating this inaugural three-part award that has business innovation, societal impact, societal emissions, and innovation impact at the same time. The Luna protocol is just that. It's a protocol, and Luna XIO as a company is really a communications provider, and the surroundings, what is required to make this a success, is that there are technology forward users who do want to go to the next level, that there are hardware providers who are making amazing advances, who can count on something like Luna, and partnership with folks who are making potential gateways, and last but not least, application providers. So I hope this has been a good introduction to Luna, and that you will be joining us on this journey. Thank you.
Fantastic. Thank you, Armand. That was great. And we do have a question. I invite anyone who would like to come off mute and open up their video if they would like. This is the time where we can have a discussion with Armand. Brian did put in a question. Do you have tags that can stand up to an autoclave?
So we are, like I said, we are really a provider of the communication. And in terms of the devices themselves, we partner with existing manufacturers. Indeed, there are manufacturers who make autoclave capable sensors and Bluetooth sensors in particular. So the answer is yes, you can find them, and we can source them for you, but not that we make them ourselves. Brian, does that make sense? Excellent.
Very good. Great. So anyone else can, type in the chat or come off mute and ask the question directly. I've got a couple questions, but first let me say, Armand, congratulations again, and thank you for that great, clear video explanation. And I think you hit all of the key things that we look for when we give out the ISSIP award. We have a panel of judges. You can go to the website and see who our judges are. They rank each one on various dimensions. And I really do like how your award this year was the best overall because it hit all three dimensions. And I think I just want to call out the energy. Making these systems so that they can get by with less energy certainly is going to add to the sustainability. And I think that was really, helped the judges score this high on impact to society. But I also like the way you open the video with the pandemic story and, the shipping of all these vaccines and so forth. I think one of the big questions on people's minds is going to be, adoption so far. Could you just maybe re-summarize, where you are in the adoption cycle? I see you've got a lot of partners, but, what does adoption look like, if you can share more on that?
Sure. So, adoption turns out to be a commercial exercise more than a technological exercise. Dealing with hardware, software is a lot more scalable, adoptable. So one of the things that you do not see on the talk is that one of the services we offer is a device tracking service. Device tracking meaning that people leave their scanners, huge warehouses. Things get left behind and lost all the time. I can't find my phone in the house. Just imagine having 5,000 people in 2 football-sized fields. So we do have a service that's not mentioned in here that makes the barcode scanners or the mobile devices themselves into something that's being tracked. Kind of the equivalent of an industrial Find My service. And that one requires no hardware because these things, already speak Bluetooth. So a lot of our initial adoption, fast adoption, is on that side of the world because, like I said, it requires no hardware. You press a button and boom, you got 10,000 or 100,000 people covered. So that's where we are in terms of biggest adoption. The temperature sensing service is very new for us, but that's extremely exciting. But again, that takes more work.
Great. And one other question I have is related to security, and I liked how you really clearly explained the security advantages. You had several types of security advantages, which seem exceptionally important in the adoption. And I know my colleagues now, I retired 2 years ago from IBM, but I was at IBM for nearly 22 and a half years. And I remember every year in our technology outlook, we would always look at the Internet of Things and sensors. And the big question that was happening inside of IBM, so I'm just wondering if you've got a perspective on this and maybe how Luna XIO might accelerate. I can see how it might accelerate the adoption for secure enterprise applications, which of course is very important to IBM. But the problem we always ran into was the fact that these really small sensors, each one, you can't charge very much for each one, or maybe you can if you've got the right business model, but we could never figure out a way to make billions and billions of dollars on something that you had to sell so cheaply. So I'm just curious if you, from a business model perspective, as you've been working with your partners. How do you see this? How do you see the scaling? Will there be like a single, the Apple of sensors who finds out how to get sensors in everything? Or how do you see this ecosystem developing from a business model perspective, and how people will make money?
That's a great question. I hadn't thought about it before, but looking back on how the internet really opened up the field, right? Because if IBM of the 60s was still trying to make all the computing devices and the networking infrastructure and the application, it could never work, right? To have a single banking console would cost you $1,500 or something like that, instead of having one cell phone that does so much of everything. What I do see us making possible, or the protocol really making possible, is that it allows hardware makers, for example, to specialize in an economic model that's appropriate for them. So, for example, making billions and billions of smart labels is really quite an undertaking, right? It takes very specialized printing of electronic devices, right? And if you want to have that sort of a scale, being able to print billions and billions in a cost-effective manner, you can't be selling it into verticals, right? Because, I don't care who you are, the biggest printer manufacturers in the world, you're still not a sensor asset tracking solution. So I do see that for each level, for each layer, we're really providing the ability for folks to specialize and have an economic model that works. So for the electronics, those printable electronics, I think will take off. Then on the application side, it becomes possible that it's just software, and you can charge it appropriately on that scale. And kind of separating the two, I think, is key to make it commercially viable and have it be expandable.
Great. Thanks, Arman. Well, we're a little over time, but thank you so much, Arman. Congratulations again. Thank you all who joined. I'll stop the recording now and make sure this recording, and maybe even the pure recording that you did, gets posted up to the YouTube channel, or that there's a link to it. So thank you again, Arman, and thanks everybody for joining.